So we're on page 469. This is solving two-step equations. This is lesson 4, and one of the students last period told me that I had it incorrect on the cohort calendar. It still said lesson 3. I'm going to change that for you as soon as this class is over. This lesson is going to be about 30 minutes or so, so just as far as timing goes. I just put the PDF of the homework that is due for you tomorrow onto Schoology, and I will put the actual Schoology assignment up later. Cool. Christian, you can change your name. When you're in the waiting room, you can't change your name, but you can change your name afterwards, so I'll remember that though as far as attendance goes. So very good. All right, so we're going to get started. Let's get started with the lesson, please. So once again, as I'm writing these notes, whatever I write, unless I tell you otherwise, I expect you to write that very same thing. A company charges $2 for each balloon in an arrangement and $3 for a delivery fee. You have $9 to spend. The equation is 2x plus 3 equals 9. Where x is the number of balloons, represents the situation. Work backwards to solve for x. So first off, we have to start with the money we have to spend. So we have $9 to spend. It's a horrible number. So the delivery fee is going to cost some money. That's only $3. So 9 minus 3 is 6. And since each balloon, here's that each word again. Each balloon is $2. That means we have to divide by 2. 6 divided by 2 is 3. So we can purchase only 3 balloons for this party. Wah, wah. Yeah, there you go. Cool. Thank you. Appreciate you helping each other out like that. That's cool. Thanks. So we can check our work with this. If we can only purchase 3 balloons, we want to verify that. So what we would do is we'd substitute back in what we had for 3. So 2 times 3 is 6. And 6 plus 3 is 9. Is it 9? Yes, it is. So we know that we can only buy 6 balloons. And forget about tax. This is just a math book. This isn't real life. How many balloons could you have purchased if there was a $1 delivery charge? So if I were to look back at that, so this is our expression here, our equation, and the $3 was the delivery fee included. So now we're just going to do 2x plus 1 equals 9. Start with the amount of money you have to spend. I have $9. There's only a $1 delivery fee. All right. Since each balloon costs $2, we're going to divide it by 2, so we have 4. We can buy 4 balloons. 4 balloons. We can buy 4 balloons. All right, so here is a map. Oh no. Here's a map of the United States of America. And before you think that I'm that great of an artist, I used it as a stencil. I pulled up a map of the United States, and last night I made this. Let's see here. 2 chats. Oh, Rob, you're good. You're good if you're typing that. Yep. So it was 2, subtract 9, 9 equals 9. Yeah, it should be 3. Because with the 2 balloons costing $2, it would go back to 3. All right, so this one here, this is a map of the United States. Now, you guys all know the order of operations is PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. But when we're solving for a variable, we are trying to get a variable by itself. We need to have the variable be on the other side of the equal sign. So it's trying to social distance. So it wants to have an equal sign between it and all the other stuff. So we are undoing it. And oh my goodness, guys, use your microphones, please. We're on page 469. So since we are undoing what's being done to the variable, it's actually going to be backwards. Instead of PEMDAS, please excuse my dear Aunt Sally, we have a, now I'm spelling this wrong on purpose as far as what I'm about to say. So instead of PEMDAS, it's reverse PEMDAS. So it is a SAD MEP. It is a SAD map. It is a SAD map. SAD map. SAD. Okay, so we have a SAD map. Instead of PEMDAS, we're doing SAD map. SAD map, because we are undoing the order of operations, so we have a SAD map. Recall the order of operations ensures that numerical expressions such as 2 times 5 plus 3 only have one value. To reverse the order of operations, undo them in reverse order. So instead of PEMDAS, it's SAD map. SAD map. A two-step equation such as 2x plus 3 equals 9 has 2 different operations, multiplication and addition. To solve a two-step equation, undo the operations in reverse order of the order of the operation. So instead of PEMDAS, it's SAD map. So with SAD map, we have to undo the addition and subtraction first, that's right here, and then undo the multiplication and division, which is right here. So for 2x plus 3 equals 9, which is what we already did with the balloon question, the first thing we have to do is we have to subtract 3. We are adding 3, and once again, this is still the same thing as being, what's being done to the variable? Well, it's being multiplied by 2 and added by, and then 3 is being added to it. We have to undo what's being done to the variable. So we have, through the reverse order of operations, we have 2x plus 3, we have to subtract the 3 first. And this is exactly how I want you to write it, and that's exactly how you'll see me write it when we do the actual examples. So we have 2x left over. We have to subtract 3 from both sides because of it's an equation and it has to say equal. 9 minus 3 is 6. 2x divided by 2, because we have to get x by itself. It wants to be social distance. It wants to be on the other side of the equation. 6 divided by 2 is 3. When you're done, whenever you have a solution like this, like 6, x equals 3, you can always substitute that back in to solve to see if that's equal to what it should be. So 2x plus 3, you substitute it in the 3 for x. 2 times 3 is 6. 6 plus 3 is 9. Does 9 equal 9? Yeah, 9 does equal 9. All right. Next page, this is the exact same situation. We have 3x plus 2 equals 23. The first thing we have to do through SAD MEP, we have to do the subtraction first. The opposite of plus 2 is minus 2. So we have to subtract 2 from both sides. We have a line there, and then we have 3x equals 21. This is that part there on number 2, that is the exact same thing of what you guys did last week. So it's just exactly what we've done with just a smaller step with addition or subtraction first. So we have 3x plus 20, or 3x equals 21. What's happening to the variable? It's being multiplied by 3. The inverse of multiplication is division, so I have to divide both sides by 3. So after dividing both sides by 3, I have 7 equals x, or x equals 7. Keep in mind that this is the same thing as this. And x equals 7 is the same thing as 7 equals x. Now this example here is the exact same thing. The only difference is we have a negative coefficient. Remember, a coefficient is a number that is stuck to the variable. So we have a minus 7. The inverse of minus 7 is plus 7. We add 7 to both sides. And then we have negative 2x equals 10. What's happening to the variable? It's being multiplied by negative 2x. So the inverse of that would be to divide by negative 2. We have y equals negative 5. Now this part right here is just like the second part of lesson 3. And one of the things that some of my students during first, second, third period had with an issue when we started our homework was keep in mind that if you have a 4 plus 1/5 r, the opposite or the inverse of a positive 4 is subtracting 4. So if you have a 4, you subtract a 4, that'll make it go away. Keep in mind that you have to have it on both sides because the equal sign needs to stay true. So now we have 1/5 r equals negative 5. We have to multiply it by the reciprocal on both sides, and the reciprocal of 1/5 is 5 over 1. So that's why they're multiplying by 5 on both sides. Okay, that's fine. You're good, Lily. So we multiply both sides by 5. 5 times negative 5, we have a positive times a negative, so our product is going to be negative. So our solution is negative 25. All right, so I'm going to go through these 3. Let's go through these 3. So we have to do the reverse order of operations. So it's said, map. And once again, I'm spelling map incorrectly on purpose because it's the reverse order of operations. Please excuse my dear Aunt Sally. And dear my excuse, please. All right, so for this one here, we are going to subtract 4 because that's the first one in the reverse order of operations. And when you do this, keep in mind, I expect you to be writing this as I'm writing this in your book. We are subtracting by 4 first because of the reverse order of operations, and addition and subtraction is first. I'm going to draw the line all the way across. So if I have 2x plus 4 and I subtract 4, the only thing I have left is 2x on the left side. 10 minus 4, back to second grade math, is just 6. Now I have something happening to the variable. I have 2x equals 6. What's happening to the variable? It's being multiplied by 2. So I need to divide by 2 on both sides because I need that equal sign to stay true and be equal. The same way that if you and a sibling were both doing the same work and one of you got an allowance and the other one got no allowance or less, that wouldn't be equal. We need to try to be equal. We're trying to shoot for equality. 6 divided by 2 is equal to 3. For B, we have 3x plus 5. What's happening to the variable? It's being multiplied by 3 and also having 5 added to it. So I need to, this is not even at the right angle. It's talking at you, you can't see my head. Okay. It's being added by 5, so I need to take away 5 because it's being added by 5 on both sides. I'm going to draw a line all the way across. 3x plus 5 minus 5 is the same thing as 3x. 14 minus 5 is 9. Now going back to last week, what's happening to the variable? It is being multiplied by 3. So I need to divide by 3 because the inverse of multiplication is division. 3x divided by 3 is just x. 9 divided by 3 is 3. And that's also 3. It's smaller. Okay. So before I move on, I'm going to pause the recording so I can pull up your video. All right, for this one here, we have C, which is 5 equals 2 plus 3x. What's happening to the variable? Well, it's being multiplied by 3, and 2 is being added to it. What's the opposite of a positive 2? Is a negative 2. And I have to subtract 2 from the other side as well. So now I just have 3 divided by 3x. Now what's happening to the variable? It's being multiplied by 3. So I divide by 3 to undo that. 3 divided by 3 is just 1. So I have 1x. All right, I'm going to challenge you now to, I would like you all to please do D, E, and F. I would like you all to do D, E, and F. So you're doing this one on your own, this one on your own, and the hardest one, that one on your own. I'm going to start writing down what you should have in about 60 seconds, maybe 2 minutes or so. So please do D, E, and F right now. So whether you're done or not, I'm going to start writing in what you should have. I'm going to talk through F, but D and E, I'm just going to write down what you should have and how it should look as well. All right, so I'm going to pause for a moment just so you guys can see how you should have done D and E. And I can double check my answers by inserting 2 into the value of x. So 2 times 4 is 8. 8 plus 5 is 13. For E, I'm going to substitute the positive 2, which is 2 times negative 5. I have a negative times a positive, so I have negative 10 plus 2 is equal to negative 2. All right, so here's this one, F. If you were apprehensive about this one, that makes sense. Now with F, we have a negative 2 that's being added to 2/3 W. So I need to find the inverse of negative 2 being added. And you can look at it like this. So if it's being added to 2/3 W, I could look at it as being subtracting a negative 2 from that, and that's the same thing as a double negative. We have minus a negative, which is going to be a positive. And a positive is the same thing as adding 2. So I'm adding 2. So the opposite of negative 2 is plus 2. 2/3 W is still left on the left, plus 12. Now I'm going back to the second half of lesson 3. So I'm going to multiply it by the reciprocal. Remember, the reciprocal is 2. Okay. The reciprocal, we have 2/3. We're going to multiply by the reciprocal, which is 3/2. And I also have to multiply this by 3/2. And now I'm going to find some common factors on this one, so I save myself a step. 2 goes into 2 once. 2 goes into 12 6 times. Now this next little step here, you don't necessarily have to write. I'm just doing it because I'm showing you all how to do it. So I have a 6 times 3 in the numerator and a 1 times 1 in the denominator, which is equal to 18 over 1. But if you would have just written this, W equals, well, it's like a Disney W. W equals 18, and it is a positive 18, is that correct? So, yep. Yeah. So W equals 18 is what you should have for that one. All right, now this one here, just imagine it's emos where their pizza is way overpriced. But anyway, Toya had her family party at the movies. It's $27 for pizza, like emos, and $8.50 per friend. Here's that per, I'm not gonna use black, can't see that. Per friend for her movie tickets. How many friends did Toya have at her party if she spent $78? So what they're doing is they're wrapping up their cost of a pizza for each friend. Once again, each or per is $8.50. We don't know how many friends are going, but we do know that she has $78 to spend. So once again, when we talk about per, that's going to be the coefficient. That's going to be the one that's connected to the variable. So we have a plus 27, or a positive 27 plus 850n equals 78. We subtract 27. Then we have what we had last week, 8.5. I don't know why they added the 0 in there. This is the first time that the book has done this, but keep in mind that when you're dealing with money, you have 2 decimal points, but it's not having any decimals in there anymore at this point. So yeah, so she can have 6 friends at her party. Good. 6 friends at her party. If the pizza cost less than that, if the pizza costs less, we would change the value of 27, or if she had more money, we would change the value of 28. I'm going to work out these next 3 with you, and then we're almost done. So we have 13 equals 1 plus 4s. What's happening to the variable? Well, 1's being added to it, and then it's being multiplied by 4. I have to remember the reverse order of operations, said mech. I'm going to subtract 1 first. I have 12 equals, what's left on the other side is just 4s. Now going back to last week, multiplied by 4, if s is being multiplied by 4, I have to divide by 4 to undo that. 12 divided by 4 is 3, so 3 equals s. For number 2, I have a negative y minus 5 equals 10. So through sed mep, I have to undo what's being done to the variable. What's being done to the variable? It's being subtracted by 5. So I have to add 5 to both sides. So now I'm just left with negative 3y equals 10. Nope. I did that same thing last period. 15. What's being done to the variable now? It's being multiplied by negative 3. The inverse of multiplication is division, and I have to make sure that that equal sign stays equal. So I have negative 3y divided by negative 3. So I'm just left with y. 15 divided by negative 3. It's a positive divided by a negative. So I know that my quotient is going to be negative. So I have y equals negative 5. So let's plug that back in here. So I have negative 3 times negative 5, which is 15. 15 minus 5 is 10. Yeah, I know I got the right answer. All right, now we got this one. We have negative 7 equals 1 plus 2/3 n. What's happening to the variable? Well, a 1 is being added to it, and it's 2/3 of the variable. The opposite of a positive 1 is minus 1. Negative 7 minus 1 is negative 8. I have 2/3 n. Now I have to multiply the coefficient by the reciprocal. So 2/3 becomes 3/2. Multiplied by 3/2. Negative 8 is the same thing as negative 8 over 1. 3 halves. I have common factors here, so I can save some trips, save some time. 2 goes into 2 once. 2 goes into negative 8 negative 4 times. There we go. So now I have 3 times negative 4 over 1 times 1, which is equal to 12 over negative 12 over 1. So now I have n, I'll do it the same direction. Negative 12 is equal to n. And that's my answer. The big thing in there is you don't have to do the simplification like I did here. You don't necessarily have to do that. All it does is just saves you a trip or saves you some time. You would have to simplify it at the very end rather than just coming out with a clean number, negative 10. You would have had, what would it have been? 16 over 3, and then you would have to divide the 2, and it would go from there. All right, last example. Serena wants to buy some CDs, because, you know, you guys are all buying CDs these days. Yeah. And a DVD. When was the last DVD you bought? CDs that cost $14 and a DVD that costs 23 bucks. She has $65. Write and solve an equation to find out how many CDs you can buy. So this part right here, some DVDs, that's indication of an unknown. And as you know, an unknown is a variable. So I can do $14 for some CDs plus only one DVD that she's going to buy. And she has $65 to spend. So she has $65 to spend. You can do this in the margin, I guess you could say. I'm going to rewrite it right here. 14C plus $23 for that super sweet DVD from 2006. First thing I have to do is through SAD, I have to subtract first. Subtract first. So I'm going to do 14C here. Equals 65 minus 23. I'm going to get my calculator out. 42. Then I have to undo what's being done to the variable again. It's being multiplied by 14. So I have to divide by 14. So I am left with 14, what was it, 3. Using my calculator, solution, C equals 3. So the answer would be 3 CDs. She can buy 3 CDs. Last little bit. Building on an essential question. When solving an equation, explain why it is important to perform identical operations on each side of the equal sign. Because the equation must stay equal. The equation must stay equal. I mean, if there's one thing happening to one side of the equation, it has to stay equal. We haven't gotten into inequalities yet, but it's the same situation of if your sibling and you are doing the same thing, you can have an argument, or you would have a valid point if it wasn't fair. And just think of the equal sign being like a fairness sort of situation. Turn off the recording.